Welcome back. In this video, we are going to talk about ABR, Area Border Router, and ASBR, Autonomous System Boundary Router. For example, imagine we have a lot of routers in one backbone area, Area 0. When too many routers are in the backbone, every router has to maintain the full OSPF database, which increases CPU and memory usage. To optimize performance, we need to use ABRs and ASBRs to structure the network efficiently. ABR, Area Border Router. An ABR connects two or more OSPF areas, including Area 0, the backbone area. It acts as a gateway between areas, ensuring proper communication while reducing the amount of routing information exchanged between them. By using ABRs, we can divide the network into smaller areas, reducing CPU load and improving performance. ASBR, Autonomous System Boundary Router. An ASBR connects an OSPF network to an external network, such as another routing protocol, BGP, RIP, EIGRP, or the Internet. It redistributes external routes into OSPF, allowing routers to learn about destinations outside the OSPF network. ASBRs are essential when integrating OSPF with other networks. Why do we need ABRs and ASBRs? ABRs help structure OSPF networks by breaking them into smaller areas, reducing routing overhead and preventing high CPU usage in large networks. ASBRs allow OSPF to communicate with external networks, making it more flexible and adaptable for different environments. Choosing the right Mikrotik for OSPF performance. Since OSPF relies heavily on CPU and memory, selecting the right Mikrotik router is important for smooth operation. How hardware affects OSPF. CPU performance. OSPF recalculates routes when topology changes occur. A weak CPU can slow down these calculations, causing network delays. Memory usage. OSPF stores a full link state database. If your router lacks RAM, it may struggle with large route tables, leading to slow performance or instability. Backbone area considerations. Having too many routers in Area 0, the backbone, increases CPU and memory load because all routers must maintain the full OSPF database. Best practices for Mikrotik and OSPF. Choose the right hardware. If you're running a large OSPF network, consider Mikrotik routers with a multi-core CPU, like the CCR series. Monitor resource usage. Use /system resource print to check CPU and RAM usage. If usage is high, you may need better hardware or optimization. Use ABRs effectively. ABRs help reduce OSPF processing by limiting the number of routers in the backbone area. This prevents excessive CPU load. By using ABRs and ASBRs and selecting the right Mikrotik hardware, you can keep your OSPF network stable, efficient, and scalable. In the picture, you can see a network design with multiple OSPF areas. The Area Border Router, ABR, is responsible for connecting different OSPF areas, while the Autonomous System Boundary Router, ASBR, is used to connect the OSPF network to external networks. This setup helps manage and route traffic efficiently across multiple areas while maintaining scalability and performance. In our lab setup, we are introducing a new Mikrotik router, Office 3, which will establish an OSPF connection with Office 2. The Office 2 router is currently part of Area 0.0.0.1, but since it will also be linked to the backbone area, Area 0, it must function as an Area Border Router, ABR. To ensure optimal OSPF performance, Office 2 should have the best CPU and memory capacity, as it will handle inter-area route redistribution and maintain LSDB synchronization between the backbone and non-backbone areas. Let's access the Mikrotik routers for Office 2 and Office 3 and configure the point-to-point IP addressing between them. On Office 3, let's initiate a ping test to Office 2 to verify connectivity and ensure that Office 2's router IP is reachable. Let's configure a loopback IP address on the Office 3 router. Let's configure OSPF on Office 3, using its loopback IP as the OSPF router ID. Ensure that the OSPF area for Office 3 is set to 0.0.0.1. We will configure Office 3 to advertise its loopback IP, point-to-point and LAN subnet in OSPF, allowing these network prefixes to be distributed within areas 0.0.0.1. Let's configure the LAN gateway on Office 3 and set up a DHCP server to assign an IP address to PC1. Let's configure the DHCP client on PC1 and verify if it receives an IP address from the DHCP server on Office 3. Let's configure a new OSPF area on Office 2 and add the point-to-point network prefix to the OSPF configuration. I have set the OSPF priority on all the routers to default for optimal OSPF calculations. If your network grows, it is recommended to leave the priority at its default setting to ensure stable and efficient OSPF operation. Now that all the OSPF routes are present in the Mikrotik routing tables, let's test Office 3 by performing a ping to verify connectivity to the loopback IP and LAN network ranges. For the final test, let's open all the virtual PCs and from Office 3 PC, check if we can ping all the other Office PCs to verify connectivity across the network. Let's take the main Office PC and ping Office 3 loopback IP to verify connectivity. We'll also ping the LAN PC to ensure proper communication. Thank you for watching, and I'll see you in the next video.